Okay, firstly, let's look at bivariate and partial correlations. Let's look at several terms here. Yeah, for the bivariate and partial correlations, this is belong to the correlation and the regression. It's very important. For the bivariate test, it's a correlation analysis. Also, it has several underlying assumptions. Firstly, the data should from the related pairs. For example, here is the samples here, right? Each dot here, if it's for the x-axis and the y-axis, if here is the height and here is the weight, then each sample is measured from one person. Then we call it a paired. The data is paired, the paired sample. Okay. Also, the pairs should be related. It means, for example, if this is the height, this is the weight, then when the height is it's higher, the person higher and also heavier. So they are related pairs. Okay. So this is the first. Second is the measurements. The scale for measurements. That means for each sample, the two variable, one variable, second variable, the two variables, the data should be interval or ratio. It cannot be the numeric. It should be numeric, and not like the gender, the male, female. Not okay. So the data should be the numeric. Okay, it should be interval. For example, height, weight, or the percentage, something like that. The third assumption is that the data can be considered as nominal. So that means the data is about to normality. Okay. Also, the fourth is linearity. Linearity means when one variable increase, another variable increase proportionality. Okay, so that means the number 4, linearity. Linearity, okay. The fifth is homoscedasticity. It means, here shows you two examples. Look, here all the samples falls more or less in the straight line. Okay, so that means all of these samples very close to one line, one straight line. Okay, it means the samples can be considered as they homoscedasticity. This is the violation of homoscedasticity. Why? Because look at here. Here is the straight line, right? And here, this sample is very close to this line. But this sample, they are far away from this trend line. Okay, so we say when the x value is become larger, then the y value, look, if it's a linear, if it's homoscedasticity, then this dot should be here. These two dots should down to up, left and right of this straight line. Okay, so they are too far away from this straight line. Yeah, drop down to here, drop down to here, drop down to here, and remove this dot to here. Then we can say that these data are homoscedasticity. Okay, homoscedasticity. Can you understand it? In fact, it's variance, equal variance. It means equal variance. Okay, so for the bivariate correlation, these 5 conditions is required. Okay, let's look at the example 1, the case 1. Here, use the data of TEE. You need to test three parts. Firstly, let's look at the variables here. Okay, IQ means the intelligence test. TEE is the entrance. The entrance examination score. And the number 3 is UNIF, the course average. Firstly, you need to test whether a positive relation exists between IQ and ITT. IQ and ITT, if they has the positive relationship. Okay, so here we firstly please draw a scatter. Draw a graph here. Okay, legacy dialogues. Scatter, simple scatter. Define. Here, whether a positive relationship exists between IQ and ITT. So here is IQ, ITT. We will want to see if they has the linearity. Okay, I think all of you has the correct scatter, right? Yes, I can see that here. Okay, let's double click the graph. And look at here. Add a fit line at total. So you can click it here. Yeah, if you don't want it, you can delete it. Okay, this shows that here is the fit line. Here is the fit line. And also you can see that all these samples as lies close to this fit line. Okay, there are no samples far away from the fit line. So that's also we can see that when the IE is growing, the TEE growth proportionality. Okay, so we can answer the first question. The results, pass to the result, and then the conclusion is that from the graph you can see that the IEE and the TEE and IQ has linearity, and also the homoscedasticity is not valid, except, okay, the linearity and the homoscedasticity are accepted. Okay, that's the conclusion. Here is the result. You can copy the result and analyze, draw conclusion. Okay, so here is the first. Okay, because all the samples falls left and right in the fit line. There is no sample far away from this fit line. Also, I can see, yes, so that means the linearity and homoscedasticity are accepted. Second, by Bivariate Pearson correlations, IQ and ITT and TEE, IQ, TEE, and course average. Okay. Okay. Yeah, so can you ask me to show the line drawing? Okay. Yeah, I'll show you again. Here, please click graph, scatter. Okay, and here y-axis is TEE, x-axis is IQ. And then, okay, here is all the samples. Then you double click. Okay. Then next here is a fit line. Click this, add fit line at total, right? Click it. Okay, then choose the linear. It's in fact it's default. If you want to choose others, then okay, you can choose others. But now you can choose the linear. Yeah, if you don't want to attach label to line, then you can look here. Yeah, you can cancel attach label to line. Then this label will cancelled. Okay, if you want to attach the regression here, then you can select the attach label to line. Right now I don't need it. Then I am pleased to cancel this one. Apply, close. Okay, got it. Okay, so you can have the label or you don't need that label. Okay, now I don't need it. I just need this fit line here. Okay, and here's the desired, right? And also you need to add some analyze. How to analyze? Here's the fit line, right? All the samples for left or right in the fit line. Yes, there's no samples far away from this fit line. So the linearity and homoscedasticity are accepted or are assumed. Okay? Next, second is this one. IQ, TEE, and course average. Yeah, please show the bivariate Pearson correlations. Okay, let's look at here. Analyze. Here is the correlate. Bivariate. And all these variables will be input into this box. Okay? Correlation coefficients. Yeah, default is Pearson. Right. Okay, then next. Okay. Okay, here shows the results of correlations. And then I copy here. Here is the results, right? Okay, so here you can see that the IQ and TEE. IQ and TEE is the Pearson correlation. The Pearson correlation, the value of Pearson correlation of IQ and TEE is 0.766. Yeah, this is TEE. IQ 0.766. Okay, and next, it's important to see here we have two stars, right? If it has two stars, it shows the correlation is significant at the 0.01 level. If it has one star, then it shows the correlation is significant at the 0.05 level. Okay, now look at here. The two-tiered significance is less than 0.001. Also called the p-value or the significance. Here is less than 0.001. So it means the correlation of IQ and TEE is very significant. Yeah. Also, here the 0.766, so it means it has a positive relationship. Okay, the linear relationship is positive. If it's minus 0.766, then it has negative linear relationship. Okay, yeah, that's the results and the conclusion of bivariate Pearson correlation of IQ and ITT. Okay, next. Then IQ, TEE, and IQ and the course average, TEE and the course average. Okay, then also the IQ and the course average, IQ and the course average, IQ and the course average, the correlation is 0.618. Okay, and here the significance, the correspondent significance is less than 0.01. So the correlation of IQ and course average is very significant. Okay, here shows the TEE and the course average. The correlation is 0.651, and also the significance is less than 0.001. Okay, so the correlation of TEE and the course average is very significant. Okay, so here shows that the correlation, all of the correlation are very significant. Here is the number 2, the answers for number 2. Okay, so you can copy it and then you can write. Less than 0.01. Okay, and then next, the third one is the TEE and TEE and the course average is 0.651. Okay, the p-value is, so that means the correlation of TEE and the course average is very significant. Okay, so number 2, whether the relationship, whether a positive relation exists between IQ and TEE. Yes. Okay. The next, whether the relationship between TEE score and the course average is significant when IQ is controlled, because we think maybe TEE and the course average, the relationship, they have relationship because the IQ because the impact of IQ. People think higher the IQ, TEE scores, and the course average is higher. So if the students, their IQ is controlled, that means the impact of IQ is controlled, then the TEE score and the course average has no significant relationship. Okay, yeah, you have a question. Then I need to stop here, okay? Okay, let's continue. Yeah, here I think I should make something clear here. You see? Anyone here? Okay, firstly, yes, I think I need to talk about the Pearson correlation. Yes. Pearson correlation. The Pearson correlation will be from -1 to 1. Okay, and if the Pearson correlation is 0, it means the two variable has no relationship, totally no relationship. Okay, if the Pearson correlation is 1, it means the two variable has the linear shape. Yeah, 100% linear shape. And also if it's 1, it means it has the positive linear shape. If the Pearson correlation is -1, it also means that it has the 100% linear shape, but it has it's not the positive, it's the negative. It's negative linear shape, linear correlation shape. Okay, that's the Pearson correlation. So if it's close to 1, then, for example, this part and this part, look at here. This correlation will close to 1. Why? Because all these samples very close to this fit line, right? These samples, yes, compared to these samples is not so close to this fit line. Okay, so when we compare this part and this part, this correlation shape will be higher than this one. Okay, and also they are all the positive linear correlation. Okay, understand? So this is the Pearson correlation, right? The data, the value will be from -1 to 1. And then here is the test. It will test if this correlation is significant or not. Here, the Pearson correlation of in IQ and the TEE is 0.766. Look here, the Pearson correlation of IQ and the TEE is 0.766. The p-value or the significance. The significance is here. Look, it's below the value. It's below the Pearson correlation. It's here. Okay, and here you can see it's 0.000. 0.000 is less than 0.001. And the default level, the default significant level is 0.05. So the correlation of IQ and TEE is very significant. Okay, understand? Yeah, hope you can understand. Okay. Next is this one is partial correlation. Okay, so let's look at the question here. Question is whether the relationship between ITT scores and the course average is significant. When IQ is controlled. IQ is controlled, so IQ is controlled variable. Okay, when we control IQ, we check the relationship between TEE and the course average. Then here we will use the partial correlation. Okay, so analyze here, correlation, partial. Yes, all of you find the correct method. Okay, and controlling for, which variable is controlled? Yeah, it says that when IQ is controlled, IQ is the intelligence test. Okay, so this variable is controlled, right? This variable is controlled. Also here, and then we will check the TEE and the course average. Okay. Yeah. Here is the control variable is IQ, which we check the TEE and the course average. Okay, here is the result of the partial correlation. I will paste it. Okay, then when IQ is controlled, the TEE and the course average so that means the correlation of TEE and the course average when IQ is controlled is, look here, it is 0.352, right? 0.53352. Okay, so it's 0.352. Okay, the corresponding significance is 0.091. Okay. Yeah, it's look here, it's 0.091, which is more than 0.05. So it means when IQ is controlled, the relationship between TEE score and the course average is not significant because it's more than 0.05. Okay, here is the conclusion, okay? It's not significant. Okay, so here's the result. Here is the analysis. Yeah, here's the analysis. And here's the conclusion. Okay, got it. So for this question, you need to output the result, this result, and then analyze it, this blue part, then draw conclusion, this yellow part. Okay, understand? Okay, now the bivariate and partial correlations, the lecture is end.